Good day.
I continue working on the repair of the 3-meter guideway of the linear motion system on the surface grinding machine. This repair has been previously covered in my videos number 20, 25, 26, and 27. The process of such a repair is complex and multi-staged, and I believe it's better to present it in parts, with each part dedicated to a specific action as it is completed. I've now completed another phase of the work, so it's time to make and publish the next video. Up to this point, I've already accomplished quite a lot. First, I conducted the necessary measurements of the guideway's condition before the repair. After that, I began the process of restoring its straightness. Initially, using the autocollimator, I determined the geometry of the guideway before starting the repair. It turned out that the wear was such that the maximum difference between the highest and lowest points on the guideway surface was slightly over 0.5 millimeter. I say, approximately, because the worn, curved surface complicates precise measurements, and extreme accuracy at this stage isn't necessary. The main goal was to get a general understanding of the guideway's geometry to know how to proceed. Then I started scraping the surface, controlling its geometric condition with the appropriate tools and instruments, primarily the autocollimator. As shown in my previous videos, the initial stage of scraping was successfully completed, and the surface irregularities were reduced by an order of magnitude, meaning the deviation has been reduced by a factor of 10. Now, the irregularities of the main prism on the guideway are no longer over 0.5 millimeters, but are around 0.03 to 0.04 millimeters. This is already a good result. At this stage, the machine is likely to meet its accuracy requirements for surface grinding machines, which according to ISO standards, allows for an error of up to 0.01 millimeters over a working distance of 1000 millimeters. However, my measuring tools and instruments, including the straight edge with an accuracy of about 1 to 2 microns, which I made myself using my own original measurement and machining methods, partially shown in video number 23. And the autocollimator, as well as the mirror holder with precisely prepared supporting prisms spaced 1 meter apart, which I also made myself, and the spirit level on a prismatic base, featured in this video, allow me to achieve even greater accuracy for this guideway, up to 5 microns over its entire 3-meter length. Thus, the work continues. With a willingness to invest significantly more time and effort, it's possible to achieve even higher accuracy, below 5 microns. I scraped each of the opposite sides of the prism separately. Although I used specially created reference support pads on specific sections of the guideway being repaired, as shown in video number 26, which not only served as depth references for scraping but also as angle references for the position of the guideway line, the angle between them, which should be close to 90 degrees, as fixed on the prisms of my autocollimator mirror stand, is now not strictly defined. This is due to minor and expected inaccuracies that occur during the preliminary scraping phase. It may be slightly greater than the desired 90 degrees, or slightly less, or it may be unstable in different sections of the guideway. It is necessary to verify the actual situation. What I see right away is that the angle of the guideway is slightly greater than the angle on the prisms of the mirror stand. This suits me at this stage of scraping. However, it means that by relying on the autocollimator readings, I am achieving straightness along the lower edges of the guideway lines, which contact the prisms of the mirror stand, from where the information is fed to the autocollimator. The upper lines, on the other hand, may become distorted, as the straight edge I use, while highly resistant to bending due to its construction, is quite weak against twisting. As a result, I will most likely experience some degree of error on the guideway surface, since I am not fully controlling the upper lines with the autocollimator at the moment. For example, you can observe how little force is required to twist an I-beam. I am applying force with a nylon tube, specifically a pen cartridge. Of course, the actual amount of twisting is minimal, but in this scraping process, it is significant. The movement of the spirit level bubble reflects the elastic deformation of the I-beam. Now, I need to understand how the angle of the guideway changes along its entire length. I need to know how this angle changes, not relative to the opposite side of the guideway, but relative to the horizon. Once I have this information, I will be able to adjust my further scraping actions to create more precise geometry for the guideway. At this stage of the work, measuring takes considerably more time than scraping. But due to careful measurements, scraping is carried out without errors, only where it should be. At this final stage of scraping, I work with a very sharp cutter, the force and thickness of the chips being small. Thus, I need to carry out the necessary measurements. To perform these measurements, I need to use a sufficiently sensitive spirit level mounted on a suitable base. I assembled it from appropriate components, which was not difficult, and it's now ready for use. A rectangular block is used, which is part of a set of universal jig components, UJC. I'll take a brief detour here. I'm curious to know if similar sets are used in the West and if you have access to such components. I've tried to find the answer to this question, but haven't seen anything like it on Western websites, which surprised me. Are they not common in the West? What do their Western counterparts look like? I use them quite often and have already assembled quite a few of these components in my workshop. They are very useful in a workshop setting. However, I haven't seen Western colleagues use these kinds of components. Please write about this in the comments. Here in Ukraine, there are many of these components. On Soviet factories, they were used like a construction set to quickly assemble various technological fixtures, i.e. technological tooling. Large factories had separate workshops with thousands of such components, which allowed for the rapid assembly of the necessary tooling for a specific task. When the fixture was no longer needed, it was disassembled back into components. There are a huge number of different varieties of these components. I've managed to collect some of them in my workshop. These components often help me fix workpieces on the milling machine table and are also useful for many other tasks. Sometimes, I even use them as part of measuring instruments. Returning to the topic. Two faces of this block will interact with the guideway, but it's important to clarify that only one face will actually be in contact, this one here. I'll press it against one of the sides of the V-shaped, prismatic guideway, and the angle of that side will be measured. As you can already see, there's a visible mark from this interaction, which appeared while I was filming the preliminary material for this video. You can clearly understand from this friction mark how the interaction happens. The mark is more pronounced along the edges, but remember, the scraping is not yet finished. It's worth noting separately that during the scraping process, I had to postpone controlling the angle between the opposite sides of the V-shaped guideway. Since I don't have a V-shaped straight edge with a pair of reference surfaces, and I'm working with a straight edge that only has one working side, the angle between the opposite sides of the prism may be slightly off. However, in this case, for this machine, there's no strict need to maintain a specific angle for the prism's trough. Here, it's 90 degrees, and a slight deviation is acceptable. Such a minor deviation from the 90-degree angle will not affect the machine's functionality. In this case, a 0.04 mm feeler gauge filled the gap. This is not a problem. However, it's preferable to keep this in mind and adjust the further scraping accordingly. As I mentioned earlier, now need to additionally control the position of both sides of the guideway prism along their entire length through corresponding measurements with the spirit level. Now, I need to check for twist, that is, whether the angle relative to the horizon is stable or how much it fluctuates. And now, I'm ready to begin this measurement. The process of these measurements is simple and straightforward. I measure the angle of each of the two opposite sides of the prism along the entire length, with half-meter intervals. This interval allows me to create a sufficiently detailed map of the surface. For measuring the angles of this guideway, the spirit level with a sensitivity of 1 arc-minute per division of the scale worked very well. Calculations show that the bubble moving by 1 division of the scale corresponds to a drop or rise very close to 1/100th of a millimeter on the corresponding edge of the prism. At this point, I am measuring the opposite side of the prism, pressing the working surface of the spirit level base tightly against it. I compensate for the gap on the second side of the prism with a feeler gauge selected to fit. I conduct the measurements and record the results. While the measurements are being taken one after another, there is a gap in the narration. I want to take this opportunity to thank my viewers for supporting my YouTube project through Patreon. Now that my YouTube channel is in the early stages of development, this support is very helpful. Your participation will significantly influence the progress of new topics, and I have plenty of them, original and interesting ones. I'll be happy to create and publish new material for you with your support. Now, I flip the platform with the spirit level and measure the second, opposite line of the V-shaped prism in the same way. Thus, the first and second sides of the prism are measured. I measure the slopes on the second, nearest line in exactly the same way. In addition to the angle deviation measurements taken with the spirit level, I have also measured the deviation from straightness using the autocollimator. Now the stand with the mirror has been moved to a position closer to the autocollimator. And now the stand with the mirror rests on the two most distant points. After this measurement, I understand the state of the general straightness of the guide. These data have been processed. I visualize them, as it will be more convenient for me to use them in this form for further scraping. These data will help me achieve straightness on each side of the prism without twist. Thanks to this information, I will understand and take into account the current state of the guideways, allowing me to scrape cast iron from the guideways only where necessary. This is exactly how I should remove the cast iron from the surface, just as shown in the animation, to get closer to a perfect, flat shape. Moreover, to improve the quality of measurements, it would be preferable to mount the spirit level on the autocollimator mirror stand at this point, which would positively affect the accuracy of the guideway geometry control. Now, there's only a little work left to do, and this 3-meter-long V-shaped guideway will become straight, with a deviation from straightness of less than 1/100th of a millimeter. The machine repair continues, so stay tuned for future updates. In the next video, I will likely finish scraping this V-shaped guideway, and after that, we will move on to the second, flat horizontal line of this linear motion pair. Thank you for your attention, and goodbye.